Okay, ons gaan gou 'n aktiwiteit doen wat baie dieselfde is as op bladsy 100 in die handboek. Maar al wat ons gaan verander is hierdie gaan 4000 wees. That's going to be 4000. Maar die res bly dieselfde. Okay, so eerste ding wat jy doen is jy moet daai ding oorteken. Hierdie is wat ons oor gaan moet teken. If you redraw this one, if it's the correct size on scale and you've labeled everything, then you will get 1 mark. It takes time to do, but you will need this redrawn in order to carry on to the next sketch that you're going to draw. The first thing is we're going to draw the space diagram, which is this exactly as it's given, but you have to draw it on scale. The space diagram, that is the ruimtediagram. So they will give you a scale for the space diagram. In this case, we're going to work on scale 1 to 100. So if they said that this is 4000, that's referring to millimeters, then we're going to say on a calculator 4000 divided by 100 if we work on a scale of 1 to 100, which gives us 40 millimeters. So hierdie gaan dan 4 centimeter breed wees en nog 4 centimeter. Then they also say that this is going to be 60-degree triangles, which is equilateral triangles. Dit is 60 grade en 60 grade, dieselfde daar. If that is going to be 40 and that's 60 degrees as well as that 60 degrees, then the part where they meet, that will be the line at the top, which is going to be member BF. So think about this in a way that you think of it as a frame structure, a raamstruktuur. So this is a piece of metal joined to another piece of metal, joined to another piece of metal. This is one long piece, and that one, and that one. And the members, or the pieces of metal, are parts that we call members. Elke stuk staal, elke lengte, is 'n lid. Ons noem dit 'n lid. And the name for these members will be the 2 letters both sides of that member. So this part over here will be called member AE. This one over here will be called member BF. Here is BF. CG, this is, just be careful with this entire length is called, that side is D. So this member here, this part of the member is called DE, and that one is called DG or GD. Doesn't matter which way you read it at this stage, but when you plot the force diagram, it's going to be important the way that you say it, because we always work clockwise around each intersection point. Then also, where this is member AE, a member is a piece of metal, but on this entire frame structure, there are forces applied. Daar's verskillende kragte toegepas. And that is this force, the 225 newtons, 275 newtons, 300 and 200 newtons. So these two are going down vertical, and that one going is up vertically. And all of these frame structures should be in balance. Hulle moet almal gebalanseer wees, wat in ewewig is. And we check this by having a look at that vertical downwards force plus this vertical downwards force, the 200 plus the 300 equals to 500. The same with this, 225 plus 275 is going to give us 500. So we know the vertical forces going up equals to the vertical forces going down. Okay, so now after you've drawn the force, the space diagram, this is going to be the space diagram. If you've drawn it on scale, the scale that they give you, if you've labeled all the parts A, B, C, D, E, and F, and G, normally that's given to you. If it's not given to you, like in the textbook, where they give it like this, just start at the top left, and along each length of each member, you put a letter. And get the habit of writing it in the sequence of clockwise, around, and then you go to the inside. So it's A, B, C, the bottom part is D, E, F, and G, which will look like this in the end. If you've done this and drawn the forces in, labeled it and drawn it on scale, then only you will get 1 mark for redrawing the space diagram. Nog nie 1 punt kry vir hom. After you've done this, and you need to draw this on your answer paper because the given sketch will be on the question paper. And remember, when we mark the paper, we're not marking your question paper, we are marking your answer paper. Okay, so after you've redrawn this one, you have to draw the force diagram, the kragte diagram. And there's a second scale that will be given to you. Where that scale was applicable to the force diagram, to the space diagram, this force is applicable to the force diagram that we're going to draw now, which is all the forces plotted together on one diagram. Die kragte diagram is al die kragte van die raamstruktuur geplot op die kragte diagram. So remember I said about the vertical forces going up and down. That's the first step. Dis die eerste stap wat jy gaan doen. You're going to plot the first force. This force's name is force AB. It's the 2 letters both sides of that force. This region here is A, this region here is B. So that is krag AB. This force over here, the 300 newtons force, the name of it is force BC. This one's name is force CD because everything on the right side is part of this region here, and that's part D. So that's force CD. And this one is force DA. So dit is hoe ons daarna gaan verwys. Wat jy eerste gaan doen is jy plot die vertikale kragte, maar dit moet op skaal wees. So, if the first force AB goes down 200 newtons, but we are working on a scale of 10 millimeters equals to 50 newtons. We can also think of it as 10 millimeters is 1 centimeter. So 1 centimeter equals to 50 newtons. How many times does 200 go into 50? 50 go into 200? It goes into it 4 times. And remember, we're referring in this case to centimeters. So we're going to draw a line going down 4 centimeters. But get the habit of starting the force diagram in the middle of the page. So that's the boundaries of the page. Draw it in the vertical line going down. And that's going to be 4 centimeters, which is force AB. So, or member AB. It's not a force, it's a member. Member is just a piece of metal, 2 letters both sides of it. So you're not going to have an arrow at this stage. So label it A and B. And the next vertical force is going to be force BC. Goes down 300 newtons. And 50, the scale, 50 goes into 300 6 times. So it's going to be 6 centimeters going down further. So realign your ruler with your first member and then add another 6, which will give us in the end 10 centimeters, which will give us point C. Again, remember, it's not a force, it's a member. Dis 'n stuk staal. Ons praat van 'n lid. So hier is lid AB en BC geplot wat afwaarts gegaan het. En jy koppel hulle stert aan kop. Dit was gewees van graad 10 of so, maar die ding is op hierdie stadium is daar nie 'n stert of 'n kop nie. Want dit is nie 'n krag nie, dis 'n lid. Okay. So die volgende enetjie is krag CD. Krag CD gaan op 275. So 275 divided by 50 gives us 5.5 centimeters. So this 5.5 centimeter, maar nou gaan hy opgaan. It's going to go upwards. So we finished with point C because this is force CD. We have point C here, so it goes up 5.5 centimeters. And that point is called point D. The last point is going to be force DA. This one is force DA. And 225 divided by 50 gives us 4.5 centimeters. So we finished with point D. We're going to go up 4.5 and then we'll finish back at point A. And remember again, the upwards forces equals to the downwards forces. So that means that after we've plotted everything going down and up, we should finish at point A, where we started. Okay. Vir hierdie streep behoort jy klaar 1 of 2 punte te kry, om net dit op skaal te geteken het. Hierdie gaan ook dan sommer nou al donker getrek word, want soos wat jy jou lede en jou kragte plot, gaan jy dit donker maak. En moenie bang wees om konstruksielyne hier te gebruik nie. So vir daai rede gaan ek sommer nou al klaar van die begin af ligte lyne verleng op hierdie lyne wat ek getrek het, net liggies, sodat as ek my gradeboog moet oplyn, I'm going to have to realign my protractor at a certain stage with this vertical line. Then I have extended lines to realign with on the vertical or for a new angle. Okay. Nou gaan ons terug na hierdie enetjie toe, and we're going to first look at each intersection point, elke kruispunt van 'n lid. So there's the first intersection point, and the principle that we follow is we always work clockwise around an intersection point. And that is the way that we name each member. So this member over here, AE, if we plot around this one, remember we're going to look here and plot there. If we have a look over here, we're going to call this member AE, reading it clockwise, A and then E. If we read this member here, going clockwise around this point, it's going to be called member ED. If we work around this member here, this force here, this member here is going to be called BF. This one is called FE. This one is called EA. Next one is going to be CG, GF, FB, and force BC. And the same over here, if we work around clockwise around this point here, this is D. So that member here will be called DE, EF, FG, GD. Okay, so you can start anywhere on this space diagram and start plotting on the force diagram, as long as you cover all intersection points. So in die algemeen gaan ons begin nou net waar A is. We're going to start with this one, working clockwise around this intersection point. The first member at an angle is member AE, and that's drawn 60 degrees from the horizontal. So from here, going up 60 degrees from the right side, going up like that, we are going to plot a line where AE is going to fit on the force diagram. So just the same angle that it's over here at 60 degrees. Remember, you've drawn this on scale. We don't have point E yet on this vertical line, but we have point A. AE, we don't have E, but we have A already there. So at the same angle over here, there's A. So that we're going to draw a line which is from the horizontal going up 60 degrees, a line over here. We've got A, but somewhere on this line, point E is going to be. So where this one lies at 60 degrees over there, we're going to realign it here with point A, and then draw a vertical, line it with a vertical line up, and there's 60 degrees, and then draw a line going through. Draw this as a light construction line. This is point A, which we just got the first part of this member. The name is AE. We've got A over here. So somewhere on this line, point E will be. So put a small letter on both sides. At this stage, this line is infinite. But somewhere on this line, point E will be. So after you've plotted this one, you can even just put a tick there to say, okay, I've plotted this one. We're still working around this intersection point. Working clockwise around it. AE has been plotted. The next one is ED. Working clockwise around this intersection point. ED is the next one. We don't have E on this yet. We only have the small letter, so it means somewhere on this line point E will be. As soon as we've defined it, we'll make it a capital letter. So the next one is ED, which is a horizontal line. We don't have E, but we have D. D is over here. So with your protractor, line up with your vertical line, the 90-degree line, and mark off the horizontal line. Extend this line all the way through. This was horizontal from point D, but somewhere on this line, point E will be. So put a small letter E over there on both sides. And now you can realize somewhere over on this line, point E will be, because this was line AE. Somewhere on this line, E will be. This is point D. Somewhere on this line, E will be. So that means where this E line and that E line crossed with each other, that will give us the defining point for point E. And because this is a member, AE, we can already go and darken this line. You can also do this in the end, but we know that it's a member over here, so you can go and darken it. ED as well. Just don't do it with a pen. I'm doing it with a pen now because I know it's going to be there definitely. But do it with a pencil first until you're completely done, and then afterwards just darken it with a pencil. Okay, so that means I've plotted this member here. Everything around this, all the members around this intersection point has been plotted. So now let's go to this intersection point. You can also go to that intersection point, or that one, or that one. Doesn't matter as long as you complete all of them. So we're going to work around this point, but we have to work in a clockwise direction. Put an arrow there just to remind us. So working clockwise around this point, DE, that's the way that we're going to say this member's name, DE, we've already plotted that line over here. When we plotted from this side, that was member ED, working around that one, going around clockwise. Now it's going to be around this one, DE. There's a difference between DE and ED. So working clockwise around this one, that's going to be member DE. I've plotted that one, so I can put a tick there. Next member around this point, working clockwise, it's EF in a clockwise direction. Then we go check, do we have point E? Do we have point F? At this stage, yes, we have point E, but we do not have a point F yet. So the problem is if you made a mistake by getting this point E at the wrong place, then you're gonna basically make a mistake again, a domino effect from your first mistake. But at this stage, again, we know that point E will definitely be there because we are quite sure that this line was line E, this one was line E, so point E will definitely be there. So we can carry on with this if you are quite sure that you're on the right track. So on point E, member EF will be at 60 degrees from the horizontal. So E we've got over here. So at the same angle, 60 degrees from the horizontal, EF will be. So line up your protractor with point E, and this one was from the horizontal at 60, so from the horizontal here at 60 degrees, we will draw a line. So this line is extended. Somewhere on this line, point F will be. We're not sure where, so we put a F on both sides. We've plotted this member now. The next one is FG, working clockwise around this point here. FG, we don't have a point F yet, we do not have a point G yet, so we skip this one for now. Working further clockwise around this one, we've got GD. This was DE, EF, FG, GD. We do not have D. We do not have G, but we have D. D is over here. and that's going to be a horizontal line. So on D, somewhere over here where we had E, G will also be on the same line. Okay, so we've plotted this line. We've plotted everything around this intersection point. Now we can go to the next one. Let's do this one. Working clockwise around this point. Let's put the arrows there to remind us that's clockwise. This is going to be member BF. Working clockwise around it. BF. We have a point B here. So that means horizontal from point B. We mark off the horizontal here on both sides. And we draw ourselves a line, which will be BF. We have point B here, somewhere on this line F will be, somewhere on the line F will be. And now we can realize here, somewhere on this line, point F will be. And previously we also had somewhere on this line, F will be. So where that F line and this F line crosses, this will be defining point F. So now we're making it a capital letter. Where that was a small letter, we're not sure where on this line F will be. Now we found F, so that's going to be a capital letter F. EF we also know is going to be a member, or is a member there, because EF here is a member. So that's going to be a dark line over here as well. So we've plotted now BF, we've plotted FE as well, working clockwise around this one. BF and FE we have plotted. FE here was at 60 degrees from the horizontal, which is the 60 degrees from the horizontal, parallel lines. So we've plotted that one. Here we've also plotted AE previously when we worked around this one. If we work around this point here, it will be EA, working clockwise around that one, BF, FE, EA, and AE we've plotted here because that is 60 degrees from the horizontal. We've plotted it there. So we are done with that intersection point. The next one, working around this point, we're going to work clockwise. The first one will be member CG. CG, working clockwise around that one, CG. We have point C, but we do not have point G. So C is here at the bottom. From the horizontal, it will go up 60 degrees. So from point C, line up your protractor with that, point C and the vertical line, and then at 60 degrees from there, that's going to be a line drawn. Somewhere on this line, G will be, because we just plotted CG, the two letters on both sides, working clockwise around that one, CG. We have point C here, so somewhere on this line, G will be, small letters G. And then having a look at what we've previously plotted, where somewhere on this line G will be, here we also have a line DG, that somewhere on this line G will be. So that means with this line CG crossed with line GD, that will give us point G, capital letter G. And that will also be, we just plotted CG, so that means that this will be a dark line, as well as FG, which is this one, which we'll plot next, is going to be a dark line. So we've plotted this one, working clockwise around that point. CG we've plotted, the next one is GF, and this is from the horizontal 60 degrees going up, which is GF. We have point G here, 60 degrees from the horizontal, just like that one there, 60 degrees from the horizontal. We're going to plot it here, 60 degrees from the horizontal. That gives us over here a connection between G and F, which over here is member GF lying at 60 degrees. So that's also a dark line, which means we are done plotting that member there. And by now we can see we've plotted all the members. On this line here, member CG, we've plotted it, we have a tick there. On this line here, GD, this D is the entire area at the bottom, so this is member GD, we've plotted it here. But DG is a member, that has to be a dark line. So connect D to G as a dark line. That means we are done now with the force diagram, die kragtediagram is klaar. Nou moet jy alle lede gaan definieer volgens hulle aard en hulle omvang. You have to go create a table where you define each member. Remember the members you see over here. We define each member according to their nature and their magnitude. So for this, we create a table. And the table will be where you list all the members. So let's first see how many members we have. If we have a look over here, AE is 1, BF is 2, CG is 3, DG is 4, DE is 5, EF is 6, FG is 7. So we have 7 members in total. We're going to go and create a table where we list all the members. The first one is a E. This one here. The next one is BF. The next one is CG. The next one is DG. The next one is DE. The next one is EF. The last one is FG. This one here. Okay. Now you create a table where you have two things to define for each member. The first thing that we're going to define for each member is going to be the nature. Okay, so the nature is the first one. The aard in Afrikaans. The second one is going to be the magnitude. The omvang. This is in newtons because over here everything was given in newtons. This alles in Newton. The nature will either be a strut or a tie. A stud of a band. Okay. A strut is a member that pushes out. A tie is a member that pulls in. That's two arrows going in. That is a band. Okay. So om hierdie tabel te skep, moet jy nou gaan kyk om hierdie tabel te voltooi, moet jy kyk na albei van hierdie die ruimtediagram en die kragtediagram. To complete this table here, you have to check both the force diagram and the space diagram. So the first one here is going to be member AE. And we check over here AE. Let me get another color pen. Okay, so we have a look at this point over here. Working clockwise around this point. keep your finger there to remind yourself where you are working at, because you're working between both of these members. So AE, this one we read it as AE because we say it clockwise around this point. We check here where is A, then we check here where is E. The direction that it goes in the sequence that you read it here, AE. A is at the top, E goes down. Then over here you go and put an arrow where your finger is pointing downwards. Then, still carrying on around this point, AE we finished, ED is the next one. Then you check here, E is there and D is on the right side. E to D goes to the right side, so you put an arrow at your finger going to the right side. We've plotted both of these members where we are working at my finger. Now we're going to the next intersection point. And again, we read it in the sequence of where we are reading it clockwise around that point where my finger is. So working clockwise around this point, it's BF. Then we check here where is B. F here is on the left. There's something that we missed. That is a member, so it has to be a dark line. Okay. So working around this one, BF. B is on the right side, F is on the left side, so it goes to the left. So we put an arrow there going to the left. The next one, going clockwise around my finger here, BF, we've done. FE is the next one. F is at the top, E is at the bottom, it goes down. Then you put an arrow going down. Next, working further clockwise around this point, BF we've plotted and we've checked the direction. FE we've checked the right direction. EA is the next one. E is here, A is going up, so at my finger we put an arrow going up. So now we can see member AE, this member here, this one here, it's a strut because the arrow goes out and the arrow goes out, so it's going to be a strut. So over here we say that is a strut of a stit. The next one over here that we've checked, member BF. Here we have an arrow going out, but we haven't checked the other side. So let's go around this point here. Working clockwise around my finger here. CG. C is at the bottom, G goes up. We put an arrow going up. Working clockwise around my finger still at this point. It's going to be CG. GF, G is at the bottom, F is going up, so this is going up. The last one at my finger, CG we've done, GF we've done, FB we check. F is on the left, B is on the right side, so the arrow goes out. So BF we can see is a strut because the member is pointing outwards. BF is a strut, a stit. Next, we have a look at this point over here. Working around this point, working clockwise around it, we have DG, then GC. So DG we check, D is on the right side, G goes to the left, so here it goes to the left. Further clockwise around this point, GC, G is there, C goes down, so here we have an arrow going down. Okay, so we can check and see member CG is a strut. Arrows are pointing out. So that is a strut. Next we have to plot around this one. Working clockwise around this point here. This is part D, that's E, F and G. So clockwise around it, D, E. D is there, E goes to the left, we have an arrow pointing to the left. Working clockwise around this point at my finger, D, E we've done, E, F is the next one, E is at the bottom, F goes up, so we put an arrow going up. Working clockwise around this point, D, E is finished, E, F is finished, F, G is the next one, F is there, G goes down, so that's an arrow going down. The last one, G, D. G is there, D goes to the right side, So the arrow goes out. Now we can complete the table and the nature of all of them. So we have next DC. Let me just check. CG DC. That's not a member. Okay. Just check 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Yeah, I missed one. So it's AE, BF, CG, DG. This one should be DG. That's DG, because here it's member DG. Okay, so member DG is a tie. The arrow points in and points in. We check the tie is the arrow pointing in, so that is a bindkrag. It's a tie. DE, this is the member DE. Arrow points in, so it's also a tie. EF, this one here, E is there, F is there. EF, arrow pointing in, it's another tie. The last one, FG, arrow pointing out and out, so this is a strat. Okay, now that we are finished with the nature, the nice thing is now you're ready. If this is correct, you have 7 marks for this one here. We have another 7 marks here with a magnitude. Okay, so this is quite quick compared to the nature. But the problem is, if you made a mistake with your force diagram here, then the nature here is going to be wrong. Most of the time, if this is wrong, the nature will still be correct, because the roundabout, the shape will still be the same here, which means that you can still roundabout get the nature of all of them. But the magnitude is very specific according to millimeters, according to the size. So don't waste your time on this if you don't know that this is 100% correct. Okay, so now to calculate the magnitude, the omvang, that is alles in Newton, it's everything in newtons. So keeping in mind our scale that was given, 1 centimeter equals to 50 newtons, we go and measure member AE on your force diagram. So AE over here is about 50, let's have a look here, about 52 millimeters. But try and work in centimeters here, because it's a bit simpler to give your final answer if you think about it in centimeters. So this is 5.2 centimeters. And then you say 5.2 times, our scale is 1 centimeter equals to 50 newtons. So it's times 50 gives us 216 newtons. So this will be plus minus. We say plus minus because it's not exactly 260 newtons, but it's round about 260 newtons. So put your answer there as newtons. Keep in mind, if this was kilonewtons, then your answer will also be in kilonewtons, yeah. But in this case, it's newtons, so it stays in newtons. The next one, BF. BF, we're going to measure in centimeters, minus 3 centimeters. 1 centimeter equals to 50 newtons, and we have that as 3 centimeters. So 3 times 50 gives us plus minus 150 newtons. Next we have CG. We have a look over here. C is there and G is there. We measure the length of this, and mine is about 6.3 centimeters. So 6.3 centimeters times 50, which is our scale, we have about 315 newtons. So plus minus 315 newtons. Remember to put in your units, because if there's no units, the mark will not always be given. The next one is DG, which is the measurement here, and mine is about 3.3 centimeters. So on your calculator, 3.3 times 50 gives us 165 newtons, plus minus 165 newtons. Next we have DE, so that's the shorter one, minus 2.5 centimeters. 2.5 times 50 gives us 125 newtons, plus minus 125 newtons. Next one is EF. It's a very small length. Mine is about 7 millimeters. So remember, we're working in centimeters. So that is 0.7 centimeters times 50 gives us 35 newtons, plus minus 35 newtons. FG is the same distance as FE. So that will also be plus minus 35 newtons. If this is then correct, that is going to give us 1, 2, 3, 4, 5, 6, 7 marks added. Okay, the mark allocation for the space diagram will be round about like this. 1 for that vertical line or force going down, 1 for the second one, 3 marks, 4 marks, 5 marks, 6 and 7 marks in total. So that's going to be 7, 14, 21, 22 marks added in total. Okay.